Every year, hundreds of millions of people contract malaria. This is a parasitic infection that's spread by mosquitoes. The parasite does two things when it grows in the body. Either it clones itself to make millions more malaria parasites in that infected individual and makes them sicker in the process, or it produces a different form of the parasite that's sexually active and specialised to infect mosquitoes, so it can spread to another human. And this week, scientists in Edinburgh have discovered that malaria bases the decision on whether to boost its numbers in an infected person or to try to spread to other individuals by counting its own population. Understanding how this works, the scientists think, might provide us with new ways to tackle the problem. Petra Schneider told me what she's found.
The parasites respond to how well they can do. If they're in good conditions, they can invest in reproducing, in having sex and transmitting to new hosts. But when their conditions aren't as well, they have to invest more into surviving in their host, and they basically delay having sex and transmitting to a new host. And then finally, at the point where the conditions are basically catastrophic and they can't survive within the host they currently grow in, they have to invest everything they can into those sexual transmission stages.
So is one strategy that one could predict from your work that if we can find a way, some kind of drug or something, that would shift the balance so that instead of trying to grow more malaria, the parasite would instead put all of its energy into trying to spread beyond that individual, there wouldn't be much malaria in the individual. And as long as we can stop it spreading to another person, it therefore wouldn't make that person very ill, and we've got a chance for them to recover.
Yes, that's exactly what the impact of this would be. If we can predict what the parasite will do in response to drug treatment or, for example, vaccination, we can prevent that patient from being ill and then put all its efforts into transmission. And then as long as you make sure that patient is under a bed net or there's no mosquitoes around, that would hopefully help strengthen the drug treatment or the vaccine outcome.
And do such strategies exist, or are there drugs that we know can shift that balance between the parasite trying to reproduce and the parasite trying to spread sexually?
Yes, definitely. At the moment, drugs, including the ones we've tested, can shift that balance, but it depends on the dose of that drug being used. Quite often the drugs used don't kill all the parasites, but you have to make sure you kill enough parasites to make sure the balance is shifted towards transmission and not towards making that person more ill.
And do you know how malaria makes the decision? How does it sense its environment and know, times are bad, I better get out of here and abandon this sinking ship? Or, wow, I'm onto a good one here, I need to grow like Billy-O?
Well, we don't know exactly how they do it. We don't know how they sense the environment. But what we did manage to find out in this experiment was that they basically look at how many of them are killed, which percentage of them is surviving into the next cycle in the host. So even though we don't know exactly how they do it, we have some kind of measure that we can look at within infections so we can predict what the parasites should be doing.
So it's not that they're sensitive to what the body's doing, it's that they're sensitive to what their own population is doing. They can count their own numbers almost.
That's exactly what this paper shows, yes.
Intriguing, but we don't yet know how.
We don't yet know how.
And are you going to be able to find out?
That would be nice, but it might take years before we reach that point.
So what actually can we do here and now with this knowledge that you've armed us with?
Well, the nice thing about this is because we know they can kind of count how many of them will survive, it doesn't really matter what kills them. So the parasites respond the same way to drugs, to competition with other parasites, probably to immunity as well. So it doesn't matter what kills the parasites, but how many of them are killed. And this is really cool because all of the different ways of killing the parasites should end up in a similar response.
So if we had a drug that could fool a malaria parasite into thinking that everyone around it was happy, healthy, and there were billions of them, that should push them all into wanting to reproduce sexually and transmit to a new individual, and that would ultimately be their downfall.
That'd be really nice. I would love to fool a couple of millions of parasites that way.